Hey Los Altos Algebra 2 students, we are going to review trigonometry ratios, sine, cosine, and tangent. But first let's review how to label the opposite side, adjacent side, and the hypotenuse of a right triangle. So given a right triangle, and we know that by the indication of the square in the corner, we have two other angles. Often those angles are labeled with a Greek letter, alpha, theta, or beta, and we're using theta today, so there's theta there, and in the other triangle, theta. So depending on where that angle is, that's how we determine where the opposite and adjacent sides are. Opposite is always across from the theta, and the adjacent is the side next to it. Now there are two sides actually next to the theta, but one of them is the hypotenuse. The hypotenuse is always across from the right angle. It's always the longest side of the triangle. In the other triangle, again, across from the theta is the opposite side. I'm going to abbreviate here. Next to it would be the adjacent. And across from the right angle is always the hypotenuse. So in right triangles, we like to look at the ratios of the sides. And those ratios have special names. We have three in particular we're going to look at. The sine function, which looks at the ratio of the opposite side to the hypotenuse side. The cosine function looks at the ratio of the adjacent to the hypotenuse side. And the tangent function looks at the ratio of opposite to adjacent. And we have a trick for remembering that. We call it SOHCAHTOA. And each of these three capital letters are for sine, cosine, and tangent. S for sine, C for cosine, and T for tangent. And then the next two letters that come after those capital letters are for opposite or adjacent or hypotenuse. So according to this first one, SOH, the sine is the trig function looking at the ratio of opposite over hypotenuse. OH. Cosine will be adjacent over hypotenuse. And the tangent function will be opposite over adjacent. Okay, so now we're going to apply this to a couple examples. So example 1, find the sine of theta. So the first thing I want to do is determine what sides I need. Since the sine of theta is opposite over hypotenuse, those are the two sides that I need. Looking at my triangle though, I don't have the opposite side over here. So I'm going to need to find that. I do have the adjacent side and I do have the hypotenuse. So I've labeled those opposite, adjacent, and hypotenuse. So step 2, if needed, as we do in this case, we need to find the missing side. And we're going to use Pythagorean theorem to find the missing side since it's a right triangle. So in this case, A and B are the shorter sides, the legs, and C is the hypotenuse. So what I have right now, I have the side that's 3, so I'll square that. The opposite side I don't have, I'm going to call it X. And that will equal 5 squared, the hypotenuse squared. So I need to solve for X. I'm going to subtract the 3 squared, or the 9, from 25. And square root both sides. And remember, you don't want the negative value, just the positive, because it's a measure of a length of a side of a triangle. So our opposite side is 4. And now I can go back and find the trig ratio. So again, because the sine of an angle is looking at the ratio of opposite over hypotenuse, it's going to be equal to, the opposite was 4, and the hypotenuse is 5. And I don't need to simplify that, it's already simplified. Okay, moving on to our second example. This time we're going to find all 3 trig ratios for this triangle. Again, let's label all the sides based on where our theta is. So here's theta. Across from that is our opposite side. Next to it is our adjacent side. And then always across from the right angle is our hypotenuse. So it looks like we don't have the hypotenuse, and we need to use Pythagorean theorem to find it. So the 2 legs, 4 squared plus 8 squared. Let's call the hypotenuse x again. Will equal x squared. Let's see, that'll be 80. I'll square root both sides. So at this point you can use the technique that we learned earlier in the week about factoring till you get primes. So I'm going to go ahead and do a factoring tree. And when I get all prime numbers, I'm finished. I'm going to go back and circle all my prime factors and then see how many pairs that I have. So I have 2 pairs of 2, so that'll be outside the radical, and the 5 that is left over will be inside the radical. So it looks like our hypotenuse is 4 root 5. So we have all 3 sides, and now we can find all the trig ratios. Sine theta, SOHCAHTOA. You can say that in your head and help you remember which trig function goes with which sides. So OH. So opposite over hypotenuse. The opposite is 4, and the hypotenuse is 4 root 5. Unfortunately, we can't leave the radical in the denominator, so we're going to have to rationalize. Also, I can cancel out these 2 4s. So now I have 1 over root 5. Let's go ahead and rationalize root 5 over root 5. I'm going to have root 5 over 5. Cosine, adjacent over hypotenuse. So A over H. The adjacent is 8. The hypotenuse is 4 root 5. Again, I can do some canceling. This time we'll have 2 over root 5. And then we'll rationalize the denominator. And the last one, tangent, toa, soka, toa. So opposite over adjacent. The opposite was 4 and the adjacent was 8. And simplify 1/2.